have the ability to share your slides or your screen.
Fantastic. All right. Thanks, Jacob. Let me share my screen, and if somebody can confirm that they can see what I just displayed, that would be fantastic.
Very good. Yeah, you can see it.
Beautiful. All right. One of the most difficult things about me is pronouncing my last name, and Jacob, you did a fantastic thing trying. It is Thabane.
I'm so sorry. Okay.
That's okay. It's Thabane. Welcome, colleagues. Thank you for inviting me back. So I'm going to share the same issues I shared the last time I was speaking to this group, which is perhaps making attempts to shift our focus away from binary thinking of statistical significance and redoubling everything we can towards doing a better job with education. And you will see how this discussion came about, which was a call to actually get rid of statistical significance, which I'm not sure would ever succeed as a community. Let me start with the land acknowledgement that here at McMaster and St. George, which is where I work, we recognize the lands on which we learn and provide care, which are the traditional territories of the Mississauga and the Haudenosaunee peoples. For thousands of years, the first people sought to steward the precious resources and share this land with others. The territories are the subject of the Dish with One Spoon, Wampum Belt Agreement, and Dish represent the shared land, while One Spoon reinforces the idea of peacefully sharing and caring for the lands around the Great Lakes in the spirit of mutual cooperation. In Hamilton, we pledge to continue to work together with Indigenous peoples in building a more just society where their gifts and those of others are nurtured and honored. I want to disclose that I couldn't think of any specific conflict of interest I would have for this presentation, but I do get academic credit for giving talks. So I just wanted to disclose that as well. Now, this was before COVID. Over 800 individuals had signed on to getting rid of statistical significance, which one would argue that is threatening my job as a statistician. So what I plan to talk to you about today is really the connection between statistical thinking in science and evidence-based practice, perhaps touch on the history of statistical significance of p-values, spend some time on talking about, why do we keep talking about this? What are the challenges? And perhaps touch on the ongoing debate that is really not new. It's been going on for years. And put forward some suggestions that others have advanced to see how we could actually shift our focus a bit. And then I'll conclude with some remarks on why you as transfusion researchers, you should care about all these issues. So this is George Wells. Many people think of George perhaps as the father of science fiction. He was born in England and had a lot of notable works. In particular, he was really a journalist with quite a number of works. But in statistics, we know him mostly as a person who made one of the most audacious predictions. He predicted that, quote, statistical thinking will someday be as necessary for efficient citizenship as the ability to read and write. And if you think about statistical thinking, what it is when we see things, we can describe what we see. If we have information, we can look at the patterns and use different types of techniques to actually see whether we can get a sense of what that information is telling us. We may wonder about, populations that generated the information or mechanisms that generated information, and think about context, quality, relevance, and alternative explanations and so on, and often benchmark all these issues with things that we would expect and whether there's any surprises deviating from what we would expect and so on. Essentially, statistical thinking in health is about advancing our welfare through research, which is really optimal use of any form of information to plan, diagnose, prevent, treat, or manage health conditions. In essence, really, when you think about it, it's no different from how we actually approach evidence-based thinking in terms of how we provides a basis for making decisions. Now, with the arrival of COVID, this became true when statistical thinking became really evidence-based thinking for every nation, and perhaps a necessary way for all citizens to rise up to the occasion and behave better. We saw graphs like this that were referring, talking about how to flatten the curve. You didn't have to be a scientist to actually follow what was happening. Bending a curve, almost every citizen was actually expected to understand what it means to flatten the curve, how they should behave to help us all flatten that curve or bend it. We saw diagrams of this form of, what happens where you wear a mask, what happens when you don't wear a mask. And this was all directed towards every citizen, which was really a way to protect ourselves. So suddenly statistics had become a necessary aspect of advancing our own welfare and protecting ourselves from the virus. And I'll come back to this issue, but before we can really appreciate the clinical relevance of any evidence that we use to make decisions or to guide our thinking, we really need to adopt statistical thinking in how we collect, synthesize, and perhaps interpret that evidence. One would argue that in many settings, I bet transfusion medicine is no different. We need a lot of pragmatic evidence to guide decisions on a daily basis. There's so many areas where what is currently being used as practice really is based on, explanatory trials with very little on whether many of those strategies or interventions work in routine care settings. The second thing we encounter is lots of barriers in translating evidence into practice, where you actually find not only do we run into issues about how we collect that evidence, but quite often it's how we actually report the evidence, with lots of things, people spinning the information for all sorts of various reasons. I'll come to many of these issues as we go along. Let me just go back to the beginnings of p-values and perhaps statistical significance as we know it today. This is R.A. Fisher, is perhaps one of the most well-known statisticians, although really one would argue that Fisher was really not a practicing statistician as such, although he came to be known as the father of modern statistics. And some people have often described him as a genius who almost single-handedly created the foundations of modern statistical science. Let me remind you, for some of you who may not know, that the fathers or founding fathers of statistics in many ways were not statisticians by profession. Like this is Thomas Bayes, who was a pastor by profession. And Fisher himself was a geneticist, and Carl Pearson, who's also attributed to a lot of the things we rely on in statistics. He was a lawyer and a mathematician. Right. So Fisher himself was born in England, and he used statistical tools or developed statistical tools to help him deal with a lot of issues he was dealing with in his experiments regarding genetics. And then one of the things he did is he wrote a book which he called Statistical Methods for Research Workers. And in that book, he did have a sentence that I would quote. He says, the value for which P is equal to 0.05 or 1 in 20 is 1.96 or nearly 2. It is convenient to take this point as a limit in judging whether a deviation is to be considered significant or not. He didn't actually just stop there. He actually continued to advocate that if P is less than 0.05, this as a standard level for concluding that the evidence against the hypothesis tested, though not be used as an absolute rule. This was perhaps the beginning of the introduction of the term significance in the literature. But Fisher proposed that you should actually think about the entire spectrum of where the p-value would be defined. And he said if P is between 0.1 and 0.9, there's certainly no reason to suspect the hypothesis being tested. If it's below 0.02, it is strongly indicated that hypothesis fails to account for the whole of the facts. We shall not often be astray if we draw a conventional line at 0.05. In fact, this was the beginning of alpha of 0.05 being introduced as the criterion for judging statistical significance. It has now become pretty much ritualistic in medical literature, and certainly we're not alone if you go to many disciplines where people collect empirical evidence and they actually have to use statistical tools to assess the utility of that empirical evidence, they rely on that threshold. This is Stuart Pocock, one of the colleagues in the UK, who often argue that, quote, the acceptance reject philosophy significance testing based on the magical 0.05 remains dominant barrier in the minds of many non-statisticians. To be honest, I would suggest that the blame goes to both statisticians and non-statisticians. These people don't just introduce themselves to these ideas. They're taught by statisticians and they collaborate with statisticians in many cases. So one would wonder, what are the practical problems or challenges with statistical significance or p-value threshold as we use them? I'll start with the first one. This is John Ioannidis, for some of you may know. He has a paper which has been one of the most highly cited or downloaded paper ever existed. And in that paper, he actually showed that there's an overwhelming number, and this is over 90% of published articles reporting p-values of 0.05 or less. And however, he did indicate that many of these claims, they showed nothing else but a high rate of false positives. And quite often, lack of statistical significance when people are doing an assessment of empirical evidence is often interpreted as absence of evidence. This is Doug Altman, who unfortunately we lost a few years ago, and his colleague, and they showed that absence of evidence is not the same thing as evidence of absence. And the reason is very simple. Underpowered studies will often yield results that are not statistically significant. This is a very good example to illustrate this phenomena where you had a combination therapy, whether you discontinue or you don't continue it. If you randomize people into it, it showed actually there was a significant reduction of about 41% relative risk. And if you look at the risk difference, it's about 7.5 in terms of number of events. And this may be viewed as clinically relevant. However, if you look at statistical significance, it's not there simply because of the small number of sizes, the sample sizes leading to a fewer number of events. So the issue then becomes, is it really that common to find results that are clinically meaningful or relevant that are not statistically significant? This was a study answering exactly that question. And they looked at cardiovascular trials, and what they were looking at is, could we find some of these trials that had non-significant results, but they were clinically relevant? So they found 127 cardiovascular trials and found that 72% of them, which was 92 of the 127, had results that were not statistically significant, but certainly, 61% of those 92 showed an estimate or the lower confidence included a potentially meaningful effects, right? So you can see that really 61% is not a low proportion. In other words, having findings that are not statistically significant but clinically relevant is very, very common in practice. Cardiovascular trials is not the only area where this happens. People have found it in so many other areas, including critical care. And I'm sure if you looked hard in your own area, you'll find lots of situations where small studies were published leading to non-significant results, but they may actually indicate some clinical utility. That's why reporting guidelines often recommend justifying the sample size, which is the amount of information one would have determined at the beginning, to make sure that you rule out statistical significance by chance, or you don't miss it if there's really important effects in the trial. The Spirit guideline has this as an item, encouraging people to design trials in ways that actually also demonstrated how much information they thought would be needed to answer the question. If you look at the console, the trend, and the strobe, they do have an item asking people, please let us know how your sample size was determined so that we can make sense in how we interpret the results. In short, p-values from underpowered trials are very difficult to interpret. And Tom Fleming is one of our colleagues at Seattle, actually often reminded people that p-values are only interpretable if you understand the sampling context, including how the sample size was determined. Things could go the other way. Overpowered studies will always lead to statistical significance. that have no clinical relevance or importance. This is another study that showed a result that was highly significant, with number needed to treat being around 50. And one would argue that, if the number needed to treat is 50, this perhaps may not be that helpful. In fact, if you look at this on a relative risk scale, 17% relative risk reduction may seem very impressive. But on an absolute scale, which is really how you measure the clinical utility of a finding, you'll actually find this may not be viewed as clinically relevant. The reason why the statistical significance exists in this particular case is because of very, very large sample sizes. So one always has to be careful. A few years ago, one of our students, who has become one of our colleagues, actually introduced the concept of fragility of clinical trials. This is Michael Walsh. And so you can think of a trial in which you're assessing one treatment versus another treatment, say treatment A versus B as a comparator, and you're looking at the rate of events, and you're actually assessing rates on the basis of Fisher statistic test. And if P less than 0.05, then you'll see you got statistical significance showing that perhaps A is better than B. Now, the fragility in this particular case would be the smallest number of patients you would have to move in order to reverse that statistical significance. So think of F as the number of non-events, people with no events, that I'm actually moving to having an event in order to reverse the statistical significance. As you can imagine, the higher values would indicate that the trial is less fragile. If it takes a fewer number of patients to reverse that statistical significance, that increase shows the trial is highly fragile. This was applied in many areas. This was trials in anesthesiology. This was pediatric orthopedic trials. This was done in spine surgery, emergency medicine, stroke. This is another one in stroke. This is ophthalmology. They all show that trials in many of these areas are incredibly fragile. In other words, it takes a very small number of patients to reverse that statistical significance that in many cases people rely on. Actually, one of my students actually did this as a summer project, looking at all the distribution of fragility indices from all different clinical areas that people have looked at. And really the average was around 4. In other words, it took about, on average, 4 patients to reverse statistical significance. The other thing about p-values is that they are routinely misinterpreted. It's a very difficult concept for most people to understand. We've seen a lot of statements claiming no difference or no effect, many of which are really misinterpretation of a p-value. And one would wonder, why do we keep on relying on a concept that's so not intuitive to most people, because they find it hard to rely on. The other thing is reliance on significance tend to promote unethical practices in the conduct of science through what's called p-hacking. If you look at what's happening and in most areas, in particular in the medical sciences, p-hacking is widespread. People have shown with empirical evidence that this is really widespread in many areas. So what is p-hacking? When we collect data, we select data or perform statistical analysis until a result that is not significant at the beginning becomes significant. This is a problem. This can be done in so many ways. Collect more data until you get significance. You can collect and analyze lots of data, but only report those that are significant. Select variables until you get significance. Exclude patients until you get significance. If you can't get any of those, you could ask me or ask Richard Cook to actually transform the data for you until you get significance. So the problem of doing this is that it makes it a lot harder for people to replicate what we have done. Science is based on replication. We do something in one patient, we replicate it in several patients, that gives us a study. But we know a single study is not good enough. We need to replicate that study in other settings to be able to see whether we get a similar results. Unfortunately, people who tend to engage in p-hacking, they don't provide all the details about what they did, and therefore it makes it a lot harder to replicate what they've done. And if you look at what's happening with retractions, one would actually see that there's a lot of studies that are retracted, and quite often many of these retracted studies, somehow they have statistical significance in them. it's very rare that you'll find something being retracted and it never showed any result that was not significant. And this tend to really promote this, unfortunate behavior of people fabricating data or falsifying it in pursuit of something significant. So this has really become a problem. If you look at the definition of publication bias, without statistical significance, we don't have that concept. It is really the propensity of journals to actually publish results that are only showing statistical significance and suppressing those that are not. So you can see how this becomes a problem. This was a Cochrane systematic review, analysis of meta-analysis in Cochrane, and showing that a lot of them really were not doing a good job in assessing publication bias. Now, if we can't trust Cochrane reviews, one would argue, what about all the other reviews that really don't have as high standards as the standards that Cochrane uses in synthesizing evidence? So this becomes a real issue. Now, if you look at what's also happening in the press and in the media, you'll often find that if something is statistically significant, it'll tend to be overrepresented in the abstract, and you'll actually also be overrepresented in the press. It's very rare that you'll find a media hype about a study for which there's no statistically significant findings. And the evidence seems to suggest that indeed this is the case. If something is significant, you bet people will talk about it in the abstract and try to suppress something that is not significant. That's part of what we often refer to as spin. And evidence on spin seems to show that people really sometimes they may actually be hyping findings of subgroup analysis because they are significant, and while the main findings were not significant, which creates a bit of a challenge. P-values have all sorts of conceptual computational interpretation problems, which this is Frank Harrell. He's kept track of all these issues. I encourage you to have a look at his website, where he's trying to really provide people with what they should be expecting, at least be aware of when it comes to p-values. Anyway, our reliance on this continues to be a challenge, and I don't think I can cover all the issues with p-values. This debate has been going on for many years, and it is not something new that we are just being aware of now. In 2016, the American Statistical Association actually put together a group of people to try and look at this issue, and they released a statement on significance and p-values, warning people. And the significance, the statement actually had 6 principles in it. The first one being that they were cautioning people that p-values don't indicate, whether the model is true or not. They're just giving a sense of how compatible the data are with a specified hypothesis or model. They do not measure the probability that a studied hypothesis is true, and they certainly should not be based only on whether the p-value passes a specific threshold. In fact, they're encouraging full reporting and transparency of all the results, not just significant p-values, which is what most fields continue to do even today. They also want people that p-values do not measure the effect or the size of an effect. And certainly p-values does not provide a good measure of the evidence for or against any hypothesis. So these are really the warnings that came from that statement. In 2018, they put even a much bigger group, actually a group of methodologies from different areas came together, and perhaps they thought maybe we could redefine a threshold for statistical significance. If they moved it from 0.05 to 0.005, this would perhaps change the practice and the way we think about statistical significance. It may actually even reduce the rate of false positives that we're thinking. And I keep bringing John Ioannidis because he's one of the people who is trying to spend his time about improving the science of doing science, which is really trying to enhance the reproducibility of many of the findings in science. So he wrote an editorial in JAMA about this issue, and I'll come to that in a few minutes. unfortunately, at the time when that paper came out, there was another simulation study that looked at how this proposed mechanism or strategy would actually work. It actually showed that, yes, this may reduce false positive conclusions. However, it was going to increase overestimation of treatment effects by a huge amount. So certainly this was not going to be a panacea. In 2019, the American Statistical Association put together another bigger group to look at these issues, and actually even dedicated a whole edition of one of their journals, the American Statistician, to the issue. And so this was really a whole movement trying to figure out what can we do about statistical significance? How can we improve the practice? And this title, the edition was titled Statistical Inference in the 21st Century, A World Beyond P less than 0.05. And in that edition, the editors actually caution people to say people should stop using the term statistically significant, right? You know, the funny thing is when I ask people, how many of you are willing never to use the phrase statistical significance in your writing? Nobody raises their hand. Myself included. And it's not surprising because even some of the people who had signed on to this issue, I continue to see their writing where they still use statistical significance. So this one was now signed on by 800 individuals. Maybe some of you may have signed it. I wasn't even aware of it until actually I saw the publication and people saying we should abandon statistical significance. It raised a lot of debate, lots of editorial. There were issues and points, very strong points on both sides, and others hailed it as a sensible and practical thing to do. Let's just get rid of it. And others pushed back against it and said, hang on a minute. If we retire statistical significance, we give him bias a free pass. And the reason is very simple. When something is reported as being statistical significance, we scrutinize it. We look at the methods to see whether the methods were rigorous enough. And Colin Began, who is one of our chief editor for our journal for the Society for Clinical Trials, he actually said the problem is really not statistical significance or p-values, it's human behavior, right? And this human behavior is often made worse and fueled by academic institutions and scientific journals and the press, trying to celebrate people who find statistical significance. And sometimes the pressures in academia also pushes people to behave in ways that it is not really pro-science. Frankly, I thought it's unlikely that practice will ever change anytime soon. In fact, there was an attempt of, some journals say, well, we're going to ban p-values in our journal. And certainly it actually showed that banning p-values did not in any way for that particular journal lead to better science. People will find something else to misuse if we get rid of p-values. But I was wrong. The New England Journal of Medicine came out saying that actually they were going to change their policies in reaction to all this debate. And I looked at the change in their policies. The only thing I really could find that was substantive, I'm not even sure it's substantive, was that they were asking people to replace p-values with point estimates and confidence interval if the protocol nor the data analysis included adjustments for multiple testing. One would argue that there was nothing new about this. Real change will only happen if we are willing as a community to overhaul our academic system and perhaps the way we approach education on these issues. In fact, really, I agree with Colin that the issue is human behavior. We should all be invested in changing this, but we need, buy-in from administrators of academic institutions. We need to educate journalists and all other people, but I'll come to these issues as we go through. All right, so other people have put on lots of suggestions, and one of the first suggestions, which is really not new, was perhaps we could encourage people to be a lot more transparent when they report trials or studies, which could help. In fact, if you look at the first consult statement, which was revised in 2010, the first one was 1996, there's nothing about reporting p-values. It just says report the results or effect estimates with a confidence interval. You could do it this in absolute or relative scale. There's really no mention of reporting p-values anyway in the concept statement. If you look at all the extensions, not a single one of them is encouraging reporting of p-values. We did this extension for pilot and feasibility studies with a group of colleagues in the UK. In fact, in our concept extension to pilot trials, we deliberately discourage reporting of p-values in reporting of results from pilot or feasibility studies, because such studies were not even intended to show statistical significance. It's about assessment of feasibility of future studies. Others have encouraged focus on clinical relevance rather than p-values, and have tried to show when we design studies, we tend to have the minimum clinically important difference we're looking for, and perhaps what we should be doing when we have the results and is to look back and say, where does that minimum clinically important difference lie relative to what we've obtained as a result, captured as a confidence interval from a study, and based on that, interpret the finding as to whether it's definitive, probable, possible, or not definite in terms of clinical relevance. Just to remind you that the concept of minimum clinically important difference really was something that came quite some time ago from colleagues here at McMaster. Others encouraged abandoning p-values threshold and use of statistical significance. And in fact, in his editorial at JAMA, Ioannidis recommended quite a number of things for the community to consider. He said we could lower p-value thresholds. We all seen that if we lower p-value threshold, it doesn't solve the problem. We could abandon thresholds and ask people to report exact p-values. Yes, we try this all the time, but we often see results reported where people are just reporting whether the p-value is less than or equal to something. Or we could abandon p-values altogether. It's unlikely to happen. We could use other alternative methods of making inferences, such as Bayesian statistics. Unfortunately, we don't have enough people trained in these methods to help people to be able to use them well. We could focus on confidence intervals and so on. And if none of these things really work, we could actually figure out whether we could take everybody back to school and train them much better. Perhaps instead of focusing on clinical relevance, we could focus on other dimensions such as patient importance, patient significance, patient centeredness. This another concept, patient orientation, that has also been presented. And really, all these things which we also have as part of our CIHR program of focusing on patient important outcomes, they may help. Peter came up with another concept that he called humanly important concept, which you can find more in the treatment of breast cancer book that you find. I'll just have some final, remarks to say. Statistical thinking, really, it's about using information or evidence in how we think about how to address issues. One would argue that we don't need statistical significance to think statistically. However, we need clinical relevance to be evidence-based, and ideally, you don't want to be in this quadrant where something is not statistical significant, certainly not clinically important. You want to argue that if it's not statistical significant, but at least it's clinically important, we could actually find ways to investigate it further. But if it's statistical significant, but it's not clinically relevant, how useful could that information be? This is where we really want to be. But it's very rare to find ourselves in that because of the way we currently do science. I would argue that perhaps we should rethink our emphasis on education, on critical thinking, statistical thinking. You don't need to be a statistician to adopt statistical thinking in how you approach science and research. I would argue that a lot of people really still need a lot of fundamentals of epidemiology and research methods. Transparent reporting is still not taught in most programs, despite our efforts to try and increase this. In fact, there's evidence showing that despite having all these reporting guidelines, the practice of reporting things transparently is still bad. So we need to do a better job even with educating peer reviewers and perhaps encourage a balanced interpretation of findings, because we're human. There's nothing that we do that's perfect. There'll always be pluses and minuses across approaches. In fact, the best lessons I always learn is at the end of every study about how we could have done things better. Perhaps do a better job with how we approach evidence-based practices and so on. Now, accurate press coverage, that's a challenge. And I think we need to do a better job in collaborating with the press in how we can best communicate science. So one would argue, who should we educate? I think we should educate journal editors and reviewers. Just because somebody is well published in a particular area doesn't necessarily make them a good reviewer. A lot of people who actually run journals and are reviewers, they do a lot of what they have to do through trial and error. I think we need to be a lot more systematic in educating people. Certainly we can educate the lay press, a lot of researchers, everybody means well, but there's a lot of people who are trusted with huge responsibility, but very little training to do what they do. Certainly the people who are the consumers in the front line of care using all the evidence need to be educated. Equally, we need to educate the public about the fundamentals of how to consume evidence. Academic administrators, we need to have policies that really support science rather than encourage behaviors that are anti-science. And certainly, I would argue that we also need to educate people who provide all the resources and the funds that support research. In fact, the American Statistical Association came back with another statement, after they put together a task force in response to all this debate, saying that really should p-values, they were not in any way in their first statement arguing for p-values to be abandoned. And they don't think abandoning p-values is actually the solution to this, but rather they're encouraging people to use them wisely. The tragedy of having misguided focus on p-value is that unfortunately it could actually lead to terrible public health consequences. In many cases, you guys would actually know about the controversy of measles and the MMR vaccine, which is the vaccine for measles. Before COVID, these were the headlines in Canada, right? The controversy actually began in 2018 with a paper that was published by Wakefield in the Lancet. The paper was later retracted. You'll still find it circulating online, but with a huge red mark in it that it was retracted. I don't need to go to the details of what autism is, because most of you are clinicians. You would understand that autism is really that condition of children having difficulty in how they relate with the world around them and so on. Now, this paper was claiming that there's a link between receiving the vaccine and development of autism in children. However, there was overwhelming evidence to the contrary. There was review after review, and all this review was showing that exposure to this vaccine was unlikely to be associated with development of autism. Let's look at the study. 12 patients in it. It was not a randomized controlled trial. A lot of the findings, or I shouldn't say the findings, the conclusions were not supported by the evidence presented in the paper. There were lots of other serious ethical issues that unfortunately were missed during the time of the review of the paper. But I would argue that perhaps, in my view, one of the most damaging things about this paper was the presentation of a p-value of the test of association between receiving the vaccine and an acid that was supposedly used as a surrogate marker of autism. We'll come to whether this was a good surrogate marker for autism. This is one of the graphs presented in the paper. You have the patients who had autism, we have controls who were selected in many ways towards in a way that will actually support the hypothesis. This is the p-value of association comparing the mean acid levels between the two groups. Guess what you see in the abstract? The p-value. You don't see a measure of association. You don't see a confidence interval of that measure of association. All you get is a very significant p-value. And of course, it's in the abstract. This is about harm to kids. And all of us, we would all pick up our arms and do whatever we can to actually protect children. And hence why this was really picked up a lot. Unfortunately, the seeds of doubt and confusion had already been planted with serious implications despite the study being retracted. This was vaccine coverage in the UK before the study came out. In 1998, when the study came out, it started going down all the way until it got to below 80%. And you can imagine, what happened when kids really didn't get vaccinated because of this issue. Fast forward to 2019, this was before COVID. Now this is happening in the US. Measles is on the rise. And, the Center for Disease Control is warning communities about measles being on the rise. They're doing everything they can to try and get parents to vaccinate children. We're having the same problem in Canada. But if you think what's happening in North America is terrible, the situation in the Democratic Republic of Congo was actually catastrophic and nobody was paying attention. This was actually coverage of what was happening there with WHO trying to warn people that measles was in an outbreak in the area, spreading like wildfire. And they were actually comparing what measles was doing. It was killing kids. In North America, we're having cases, no deaths. But in the Democratic Republic of Congo, children were dying much higher rate than Ebola was killing people. And nobody was actually paying attention. In fact, by 2020 January, over 6,000 children had died from measles. All right. Now, to be honest, I'm not suggesting that p-values in particular are to blame for this problem. All I'm saying is that really a lot of this were driven by lack of resources and limited access to care. Imagine all the money we're using trying to fight anti-vaccine movement here, and how much of that we could use to help other countries like the DRC to deal with the lack of resources that they have to live with. I'm just saying that we are actually, we could be much more helpful to other countries that need help instead of actually using resources to fight the anti-vaccine movement. The world could be redirecting all these resources to help. A lot of what's happening is really the movement, the anti-vaccine movement, it's alive in North America, and it's mostly based on flawed science that was actually debunked and retracted. In fact, the CBC had a program in the marketplace program showing that this movement was strong, very, very strong. If you want to follow this, you can find the program online. Unfortunately, as it turned out, actually the author of that paper is also at the center of the movement, and which doesn't surprise me because, anytime you're dealing with pharmaceutical companies and then you're dealing with babies and things that are harming children and all this stuff, everybody says, this is it. There's companies that are usually out to make money at the expense of our children and all this stuff. All I'm trying to say is really sometimes, these things can happen. We didn't think we'll be in the era where social media misinformation can spread so quickly, and that misinformation about that debunked study continues to spread quite rapidly across. What I've just shared with you, we put it together as a paper which you can have a look at if you want to get a sense of what we're talking about. Certainly, I would argue that statistical significance is not really the same as all the different dimensions of clinical importance, and no wonder why people are saying we should get rid of it. But certainly one would argue that, the evidence is clear. Getting rid of it is not going to be the answer. I think we need to do a much better job trying to focus on education of all the key stakeholders, from people who generate the evidence, those who synthesize it, and those who certainly have to use it to make decisions about how we provide better care. You'll also find part of this presentation somewhere on YouTube, I think. I think I'll stop right here and stop sharing, and then we can have some questions.
Dr. Thabane, thank you so much. Such an interesting talk. Before we open the questions, I'm just going to direct people to the chat where I'm posting a link for the survey to fill in the evaluation. Oksana has submitted a question to the chat. I'll read it out. Thank you for a very interesting and thought-provoking presentation. I'm not sure I understand how we can gather evidence that is both clinically and statistically significant, the top right quadrant of the graph, without using some sort of threshold of statistical significance Or is the fundamental message that we need to shift our thinking away from this concept of benchmark and focus on confidence intervals associated with results, and then adjudicate whether results are clinically relevant? Further, how can we believe anything published to date in literature? So, a few questions in there. I'm going to take a stab at that.
That's a very good question. I encourage everybody to read John Ionides' paper of why most literature today it's actually false. And he does have a hypothesis of different things one would actually have to take into account in assessing whether anything that you're reading is credible. So it's a challenge. The concept of statistical significance, in some ways, we're not saying it's completely useless or should be thrown away. All we're saying is it should be approached cautiously in design of the studies and certainly in interpretation of the findings. That shouldn't be the main driver of the message we get from a study, which unfortunately, in many areas, it tends to be a driver of what gets published by editors and reviewers, and certainly what gets used by people who consume science because they're focusing on this is significant. So I could use this to actually change my practice.
I think a really important takeaway, is that we know that human beings tend to resort to heuristic, or kind of rules of thumb thinking. It's a shorthand to get make decisions quickly and think fast, as the saying goes. But we have plenty of examples of that in transfusion medicine. We get very focused on a transfusion trigger of 70, meaning that as soon as something dips down to 69, somebody leaves to transfuse, and if it's sort of 71 or 72, then they assume that this person is perfectly well. And that similarly with quality indicators that we use for good transfusion practice, we can get absolutely obsessed with these to the point where we're doing the equivalent of what you call p-hacking and trying to alter our practice to meet a quality indicator, sometimes to the detriment of the patient. So it's hard, because you're asking people to bring in more nuance and more sophistication in their thinking when we're naturally wired to have rules of thumb, because that's how we get through our workday. I wanted to actually just ask your opinion quickly, if I could, about a trial that just came out recently, which is creating huge buzz in the medical and transfusion medicine world. And I'm just going to share my screen if I could.
Absolutely.
So everyone is talking about this study, looking at an association of intracerebral hemorrhage with receipt of transfusions from donors who later had intracerebral hemorrhage. And if you look at the abstract and under the results, the word that jumps out is statistically. Where is it now? Let's see here. Had a significantly higher risk. If that word significantly had not been there, probably no one would have read this paper. It's that word significantly got everyone's attention, and we're all diving into this paper. It's going to be the subject of journal clubs, and that's for the best. If they had not put that word there, this paper might have been ignored. And it just sort of makes you, I guess I want to know what your opinion is on the way that this was phrased. Was this a good way of putting this, or was this misleading? The way they reported this, they did provide their p-values, as you see in here. They also have their confidence intervals. How do you think of if you were going to evaluate this abstract in terms of its language, what would you say?
Well, I don't know what I would say, Jacob, because remember I asked you, I said one of the recommendations coming from the American Statistical Association group was people should stop saying things like this, right? Mm-hmm. And you ask people, when I give a talk, I say, how many of you will stop saying that? Nobody raised their hand. So to me, this is not surprising, right? Would I have recommended to this? You bet if I actually even made an attempt to discourage my colleagues from writing that statement, I would lose it. I would lose the vote. Yeah. Why? Because people want to publish in JAMA.
Yeah, and like this paper would have been completely ignored if that
Absolutely.
word
Yeah.
significant was not
And
there.
they
Yeah.
know that that's what reviewers would be looking for.
Hmm. Hmm. Yeah, it's kind of, it seems like it's a hard wind to push back against. But I think maybe what's important for trainees is to know that there's nothing sacrosanct about a value of p less than 0.05,
Absolutely.
and therefore resist the urge to start manipulating your data to get that. Like just report
Yeah.
the results as you had planned them, as they are,
Absolutely.
and
Absolutely.
yeah.
Yeah.
Um,
Now, the unfortunate reality is that so we have the guidelines that are encouraging people how to, report things and all that stuff, but the evidence is also very clear that nobody's adhering to these guidelines.
mhm. There's another question in the chat here from Raza, which I'll read out about supposing the p-values persist, how strictly should we apply multiple testing correction to p-values? This is like a Bonferroni correction. We learn it in stats courses, but we see it rarely in reporting. Is it worth being strict about? And in the same vein, if 0.05 is not sacred, can you say something like the results trends towards a finding that we find highly plausible based on clinical experience? So I
Mm,
guess question about language. So first question about the statistical methodology, and Raza, this will come up in a later talk in this cycle about subgroups, but and multiple comparisons. But the question about using the term trends towards, is
yeah.
that
Well, it's interesting because the word trend in science, we use it to describe something that's time related, and we're seeing how this uh, particular thing is changing over time. Now, think of it. In this particular case, you have a finding, you're assessing, is it significant, not significant? And if it's 0.048 and somebody says actually, 0.52, somebody says it's trending towards, as if it keeps moving. Just give me one more study that will actually show significance. Do you see what I'm saying? So the word trend is misuse of that word. That's the first thing, right? Either
mhm,
something is significant or it's not significant, not trending towards significance because it's not a moving target. Um, you know, what about adjustments for multiple testing? So this actually relates to how we design studies, because how we design studies in many ways drive how we're going to interpret those studies. If we're designing studies to actually show that something does more good than harm on more than one outcome, right? It makes sense that we should be guarding against making false conclusions across all those outcomes. And therefore, adjustments becomes essential in order to guard against false positives, right? But this Rasa is fine. What is true? I mean, that people don't do it when it's time to report the results. I've seen situations where people have talked about adjustments and all the stuff, but when they report the results, no. Why? Because if they did an adjustment, they're not seeing significance. So they see significance if there's no adjustment. And they feel like, well, if I get at least one significant, I'm salvaging the trial.
right?
Uh, right?
Yeah.
I've been involved in situations where we didn't get any significance, and we get a significant in one of 10 subgroups, and and my colleague said, "That's it. Clinicians have always wondered about this, and now we've shown it's significant. We should emphasize this in the abstract." I try to discourage it, and I've lost the vote.
Yeah.
Right?
Yeah, you're marketing your paper in a way, and then you need your hook.
Yeah, they say
Okay.
you need that hook. I like that term. They say you need
Mhm.
that hook, right?
Mhm. Okay, well, listen, we're at 1 o'clock now, so we will have to wrap it up. I think Dr. Thabane is such a fantastic talk, and there's so much stuff to ponder over here. Again, everyone, please take a minute to fill out the evaluation form in the chat section, and we will see you in a month for our next speaker.
Thanks again for inviting me.